continuation with the importance of testing. In the last class, we saw a few items about how the faults are unavoidable and why they need to be tested, and which is what is the impact of the cost on testing as the design progresses further in the life cycle. And we saw what is the electronic system. It is basically chips assembled on the PCBs and PCBs together assembled as a system. That's a system. We'll shall see about how the testing can happen. Testing can happen at the IC level, can happen at the PCB level, can happen at the system level, and it can so happen at there are various stages of testing can happen. So these are some of the things what it can do. And so this VLSI testing is very important. So it's important to everyone, all the stakeholders. So who are the stakeholders? The designers, product engineers, test engineers, the managers, the manufacturers, and the end users. So it's important to everyone. So extremely important, right? So understand the concepts very clearly and how do you apply the concepts. That is the focus of this course. Okay, so how the testing is important. You can take a pen. Point a little bit better. So this is a DUT, or design under test. It's also called circuit under test. What you need to do is you have to apply inputs. There are n inputs and n outputs. You apply inputs on all the inputs. Then you observe the outputs, all the outputs, right? Observe, note the keyword, right? Generate the input, control the inputs. Note the keywords, we'll see that later. What is control? What is observe? Write down very clearly in your notes. Controllability and observability. You have to control your inputs, then observe the outputs, right? It's called input test stimuli. Stimulus is something. What is a stimuli? It stimulates something, right? You look at the English dictionary again. Everything is you have to understand the concept. So relate that to example. I'll pause for a minute. Okay. Hope you thought about good examples. What is a stimuli and stimulus? Okay. So stimuli, you understand what is the output response analysis. We all know what is the output. We all know what is the response. We all know what is analysis. So we have to do that. Okay. So you link them and understand. Pause for a moment. Understand what is output response. Pause the video for a minute. Okay. Now you understand what is output response analysis. So what is the output block has to do? So it has to provide the correct data for all based what given set of inputs should generate some output, and the output response analysis block will compare the output with the what is the data expected with the given input and compare and decide the test has passed or failed. Right? We spoke about how do you check for your phone in the shop. You have to boot it, you have to access the Wi-Fi, you have to do some active API, you check the user interface, a bunch of things, right? On a test phone or a proper phone, right? So that is the testing. So you know what to expect. So you compare the actual data and expected data. That's called output response analysis. So let's see why testing important. So we have seen this flow already. We have a design requirement or specification. Based on the video design, we said architecture, microarchitecture, RTL coding, everything. We spoke about design verification. We did the very first lecture making of SOC. Then we do something called fabrication. In the last class we discussed about TSMC, global foundries, etc. Right? And wafer test. So once you do, we saw what is a wafer. Let me quickly explain what is a wafer. Hope I can draw it. So let's say wafer is typically circular in color. So my drawing is very bad, so excuse me. So it came like a circle. So red color is a wafer. You take a green color, and this is a die. Small chunks of a wafer. They'll be repeated multiple times. Sorry, they'll be all equal size. Again, pardon me for my drawing skills. I'm good in drawing, but not in the computer. Right? So these are the green ones are called dies. There are many dies, not DYE, DIE. So DIE has many meanings. It's not living up the life. That's not the one. This basically die means you look at the Wikipedia, right? Google or Chat GPT, wherever you want, right? But understand, you would have read my yesterday's article. Understand it appropriately, right? Chat GPT is just a tool, but it's very extremely useful. Like your programming language, like Python or C++ or Verilog, AI is a useful tool. I don't mean to say disagree. You have to use AI tool, but learn to use it appropriately. Right? That's what I'm saying. Right. So these are all die, and there are many dies of same sizes within the wafer. Right. You have to understand what is the wafer and what's a die. So we tested the wafer level. Then you once you test the wafer, you find out what is a good die and bad die. You cut out the actual dies, you make that small, you cut that out with the machinery, cut that die out, and good dies will get packaged. So we do a wafer. So after fabrication, you get the wafer, you test the wafer, you take the good dies after testing, you package them. So packaging will have this kind of wires, right? So let's see what is the package. You would have seen in your labs, right? IC testing. So this is a package IC, package die, and your inputs. Dual in package is very famous, right? What is in 7404. We have the pins, right? So you package it that way, and once then you do package level test. There's a lot of levels of testing as I told the previous stage, right? Then you do something called quality assurance. Then you do final test. So the final test after that, it goes to software integration testing. Testing is very huge. If you're interested, but it's focus on digital testing. This particular course, there's analog testing, there's system testing, multiple. That's outside the scope of this particular course. If you're interested, time permitting, priorities, we can talk later as advanced concepts end, right? So a lot of levels of testing is required, and there's something called stress testing. That's extremely important. What is the stress? Pause the video for a minute and think, what is the stress? Please think. Okay, now that you thought about the stress, you know what is the testing? What is the stress testing? Take a pause the video and think. Okay, now you understand what is stress testing, right? So it's basically you are under stress, you test yourself, you break, right? You are under severe stress, exam is coming. You're studying till 2 a.m. or 4 a.m. in the exam, and only 8 a.m. is the exam. You study about 5 minutes before exam also. I've seen, I myself have did that in the past when I was in college. Right? I studied throughout the night one day and till 4 a.m. or whatever, one of the important exams. One of my friend is Alok Srivastava in IIT Kanpur. He was my first semester, which was my opposite of my room. He comes at 9 10 p.m. and says, Hari, I'm going to study throughout the night. You wake me up at 8 p.m. at any cost in the morning. Yeah, he was my best friend, and unfortunately, he discontinued and went towards civil services. I have to dig up where is Alok Srivastava, right? So under stress, we all falter, right? Whether a cricket match, last 5 hours you try to hit, or football, or any game, right? So you have to manage the stress. So there's something called burn in. You get burnt out, you say, right? Under stress, oh, I'm burnt out. I know I need to do my hobby. I need to go to a movie. I need to go to a party, right? I need to go to a mall. I need to eat food. I need to talk to my friends and parents, whatever, right? So everyone has their own stress busters, right? Or you have simple, you take that smiley ball, the sponge ball, you start keeping under, like, squeezing that sponge ball. That's a good stress buster if you don't know. I do that sometime, and I see my close relatives do that very effectively. That's recommended by the doctors. Keep a smiley ball with me and keep trusting that you're under stress. So burnout, you see, what is a burn in? There is something called HTOL. HTOL. We'll see that something related to hot temperature. We'll talk about it later in a few weeks, or I'll give a self-study material for you if you're interested. So that's something called burn in test. So you have to test your chip under stress and in high temperatures. You have to supply very high voltage. You have to test and see how does it respond. We talk about how we respond under stress. We saw, right? How the chip respond under stress. Because there are extreme conditions. If you take automobile, right? You have to test the automobile. Your car or a bike has been tested properly. If it doesn't, the car or bike doesn't start at home, you're good. You take a Ola or Uber and go. But what if it started well? You're in a peak traffic in a traffic junction. Say in a city like Bangalore. Chennai is not that traffic. Okay. Hyderabad and Bangalore are notorious. NCR region is very notorious. Delhi side, right? And so you look at how the vehicle stops for whatever reason. You didn't apply your clutch properly or whatever, right? Or the vehicle has a manufacturing if it stops, people keep honking at you and your stress level goes up, right? So that's an example. So you don't want the vehicle to fail when you are on the road, right? So what do you have to do on the road? People honk at you, you get stressed, and you have to push you to the corner, you need some help to push to the corner of the road. We have seen, I have faced all those things, right? So your automobile testing is very, very important. Reliability, stress testing, all those things are very important. All the corner cases or extreme cases, you have to test it properly, right? So failure mode analysis, which increase the defect-free device. We'll talk about what is FMA. Please write down what is failure mode analysis called FMA. There's something called RMA, return material analysis. Please write down. We'll talk later in the course. FMA and RMA, right? Extremely important concepts. Please write it down. Take your notes. And verification and yield are important in VLSI testing. Why so? We shall see in the next slide. Okay, I don't know it's getting recorded or not. I'll break into 2 20 minutes, so I don't waste my effort. It's about 10 minutes into the video now. I'll probably break the video in another 5 minutes or so that my effort doesn't get wasted. Right. So why testing is important, right? So you have to test the design architecture. You have developed in Verilog, C program, system Verilog, Blue Spec. So you have to write your architecture at that particular level, and you simulate them. Make sure that your RTL is or a system C level or program is equal to functional specification. That's called verification. That is verification. So verification and testing are different. We are going to see that soon. Let's understand the verification first. You have to understand what is the design. You have to understand what is the verification. Then you have to understand what is testing. Then you have to understand design for test. Extremely important. You don't have the required prerequisites like I don't know how much you are successful. Okay, please ask questions. You should know how to design. You should know how to verify. You should know how to test. All three are different. Once you understand all these things, then only you design for test. Extremely important. At register transfer level, so we have sequential and combinational functions and data path and control path we saw in our class. Once you know how to do microarchitecture, you should design in terms of data path and control path. It should be verified before synthesis, right? So that should happen. So it's called RTL level verification. You design it and you verify it. So synthesis produces gate level design, as we saw in the how to making of a chip. The first intro class we saw that. The synthesis takes the RTL as an input. It takes the technology library as an input. It takes the constraints as an input, and it verifies the details of the correct functionality. And so that transfers into a netlist. Netlist is just a connection of gates and flip-flops using a wires, and it connects them to the VDD or the ground supply signals as optional if needed, if the person is needed. And we do physical design. If you know how to design a printed circuit board, or you go through a video, I'll send you a material if you want. I'll have a notes, and I'll put the notes. You have to understand how to design a PCB. If you understand physical design, I'll put the notes in the reference material section. If you have time, go through that. That's extremely important. If you're interested, I'm going to do a workshop or awareness session on PCB and a workshop on PCB very soon. Maybe next month. I don't know when. Right? But there are intentions. But man proposes, God disposes, or nature disposes that way, right? So you have to face the physical components, your gates and flip-flops, you have to face it. Inside the library, the gates and flip-flops will be mapped to the CMOS transistors or respective transistors based on the technology library. That's called libraries, technology library. Then you have to connect all the transistors to verify the final design is meeting the timing, you're meeting the operating frequency, you're meeting the voltage specification. There are a lot of crosstalks. For that, you have to understand the PCB, signal integrity analysis, reliability analysis. You do all those. You do something called OCV, on-chip variations. There are a lot of factors. If you understand how to design a PCB, you'll be a good physical design engineer. And tools. The entire chip design is full of tools. The simulation tools. RTL has design tools. Simulation has the tools. Verification has the tools. Testing has the tools. Right? Physical design has the tools. Artificial intelligence is a tool. Right? So use your natural intelligence tools. You have to give a constraint. Even if your brain, right? Let's say I'm idle today for half a day. What happens? My brain keeps going. Oh, let's go to a movie. Let's do this. Let's do that. It goes in all different directions. I need to constrain my mind or the brain. I don't know what's the relation brain and mind. I'll have to investigate. Let me find a time and that article. Please remind me. What is the brain? What is the mind? I want to understand. Mind is very difficult to control, and you should not control the mind. If you control the mind, you touch the mind, it's a devil's advocate kind of thing, right? And you have to constrain it, you have to guide it properly, right? Don't touch the mind. Mind is very difficult. You touch the body physically, body and mind, you say, right? Or body and soul, you say, right? So body and mind has a very close relationship. So physical and mental, both has to be balanced. What is the mental thing? You say mental, people think you are mad. No, that's not that way. When body and mind has to work hand in hand, it should work synchronously. You don't know what is synchronous and asynchronous, right? If you know, please pause and ask me a question. If you don't know what is synchronous and asynchronous, okay, ask me a question if you don't understand. The tools are extremely important. Okay, so let's see next slide. So design verification takes time. Typically 70% of the life cycle is verification. Right? It fails to detect the design errors. Any amount of verification is not sufficient. The verification manager or the director controls the tape out, right? Or the thing. So verification extremely key thing. How do you know you have verified it thoroughly? You'll see in the next semester course in the system, in the Verilog, system Verilog and verification. So that is extremely important. Take 70% of the design effort in the your overall effort to tape out goes in verification. A lot of people work on verification. There are different levels of verification: block level, right, subsystem level, and IP level, subsystem level, chip level, system level. Lot of verification. Okay. So I'll stop here. Yeah, bottom line again. Bottom. What is the bottom line? Your profit and loss in the industry is the bottom line. That's what we call the bottom line. So what we say is the bottom line here, design verification economically significant as it takes significant impact to time to market. Time to market. Think about it. What is time? What is market? What is time to market? You think about it. I shall resume the video soon because I want to make sure it's recorded properly. Until then, bye bye.